Welcome to Brain Vision.
So for the penny to stay on top of the block at all times means that there will be a normal force on the penny from the block exerted upward. So in this diagram, we see that this is the spring, and then this black square is the box or the block, and the red small rectangle here is the penny. So that means there will be some normal force acting upwards due to the penny being in contact with the block. So if we just take that downward direction to be positive, so if we say that downward direction is positive direction, that the net force on the penny will be F net equals to mg, which is acting downwards. That's the mass, m is the mass of the penny, minus Fn, that's the normal force, and that's equal to the resultant acceleration A times the mass of the penny. So now solving for the magnitude of the normal force, we see that Fn is equal to mg minus ma. Now this expression is always positive if the acceleration is upward, and A is of course less than 0. So there is no possibility of the penny losing contact while accelerating upward, because I mean, for that being, if acceleration is upward, then as we mentioned that A is basically less than 0, since positive direction is downward. So if downward acceleration to be larger than G, the normal force then would go to 0. So that's something that is not possible. So that means normal force cannot switch directions, which means that Fn cannot be greater than 0. So the limiting condition here is A down equals to G. So that's the maximum value for the acceleration. So if A down is equal to G, we see that normal force will be 0 here. Now, this is the maximum value for the acceleration, and for SHM, we know that A max is equal to omega squared A, which is equal to K divided by M plus M, where big M is the mass of the block. Now from there, and of course we have to multiply A with that. So from there we can write K by big M times A, since big M is very greater than small m. Now we can equate these two values for the acceleration, and we see that A max is equal to K by big M times A, that's equal to G. So A is equal to mg over K. So to summarize what we did here, or what the argument that we did here, so we considered downward direction as positive. Now there are two conditions that we considered here. First is if the acceleration is upward, that means if A is in upward direction, which means A is less than 0, then this Fn should always be positive. So there's no possibility of penny losing contact while accelerating upward. But if the acceleration is downward, or if the downward acceleration is to be larger than G, that means the normal force would go to 0. So basically, if this block is going down with more than G, then there will be no contact between the penny and the block, so the normal force would go to 0. And since the normal force cannot switch directions, so Fn has to be greater than 0, and that condition allows us to make G equal to the acceleration. So this is the condition that allows us A down equal to G, and from there we can write that the maximum acceleration possible is G, And we know that Amax is omega squared times the amplitude, where omega is the angular frequency. And we converted that in terms of spring constant and mass. And since we know that the mass of the block is very, very greater than the mass of the penny, so we can ignore small m here. And after that, we actually equated that expression to g and solved for the amplitude. All right, thanks for watching. I'll see you next time.